friends, welcome to my channel. So in the second part of the lecture on ligands in coordination chemistry, today we will learn about the ligands which are classified according to their donor and acceptor properties. It's an interesting topic, so let's get started.
Hi friends, so we had learned about the different kinds of ligands based on the density of the ligand donor atoms in the previous section. So we had seen that the ligands can be classified based on the number of donor atoms which are attached with the central metal ion. Now in this section we will discuss that apart from the density factor, ligands can also be classified based on the donor and acceptor properties. Okay, so we had previously discussed that ligands are mostly donors because they donate their electron pairs to the central metal ion. But in this section we will see that how they can act as acceptors also. So based on these donor and acceptor properties, they have been classified majorly into two types. The first category is the ligands with one or more lone pair of electrons. Now this category has been subdivided into two more subcategories. The first one being the ligands with vacant pi orbitals. Okay. And the second category is the ligands with no vacant orbitals. Okay. We have seen that the ligands contain the sigma orbitals which contain the donor electrons, right? But in addition to the sigma electrons, so they contain in general the sigma electrons which are in the sigma orbitals which act as the donors, right, which donate their electrons towards the metal atom. But in addition to the sigma orbitals, these kinds of ligands, they also have the pi type of orbitals, pi orbitals which are vacant. And what is the use of these pi orbitals? These pi orbitals can accept an electron from the metal, right? So the pi electrons of the metals are accepted in this vacant pi type of orbitals. That means the ligand contains the vacant pi orbitals as well as the filled sigma orbitals. So two types of orbitals can be found, and the best examples of these kinds of ligands are the CO carbonyls, NO nitrosyls, okay, then the cyanide and also the isocyanide, then R3P, that is the trialkyl phosphines, and then some unsaturated organic molecules. So if you just go through the fourth course about the advanced structure and bonding in chemistry, where I have dealt with the molecular orbital theory, then you can see the molecular orbital diagram for the carbon monoxide molecule I have mentioned there. And in that you can just go through and you can just see that the carbon monoxide molecules, they contain the sigma non-bonding electrons, right? These kinds of electrons are not involved in any kind of bonding. That means they are free for donation. So these are in the sigma molecular orbitals. So these are the donor electrons, right? Donor electrons which can easily donate its electron to a metal ion. And in addition to that, this carbon monoxide also contains the pi star antibonding orbitals, right? Antibonding molecular orbitals which can accept an electron from the metal, because these pi star orbitals, they are vacant. In short, I'm explaining that what happens in the carbon monoxide molecule which can act as a ligand. Okay, so this is how we have the non-bonding donor electrons also in the carbon monoxide, and the vacant pi star antibonding molecular orbital also which can accept an electron from the metal. So it can accept an electron from the metal ion. You can show it like this. Okay, so you can see that sigma is donating towards the metal and L is the ligand, M is the metal. So the arrow towards the metal is the sigma. The sigma electrons are donated towards the metal, and in turn the metal pi electrons are accepted into the pi star antibonding orbitals or the vacant pi orbitals of the ligand. Okay, so that arrow from metal to ligand is pi, and from ligand to metal is sigma, and this kind of ligands are known as the sigma donor pi acceptor ligands. Okay, then the next subcategory is the ligands with no vacant orbitals. So these are the normal general ligands which do not have any vacant orbitals to receive any of the electrons from the metal ions. So that means they are simply the donors, right? So they are simply the donors. They contain the donor electrons, and you can categorize, you can give the examples of normal simple ligands that we had seen as the unidentate also. So neutral unidentate ligands, ammonia, water, halogens, these fall into this category, which do not have any vacant orbitals to receive any of the electrons, but they can only donate electrons to the metal atom or metal ion. Okay. Now the second category is the ligands which have no lone pairs, right? They do not have any lone pair of electrons as we had seen previously, but they have the pi bonding electrons. That means the nature of the electrons that act as donors to the metal ion are the pi electrons, right? Not the lone pair of electrons or the non-bonding electrons, but they are the pi electrons, right? So these are quite interesting ligands, and the examples of such ligands are also very interesting, mostly the organic compounds that contain the pi bonds like ethylene and then benzene, okay, and also these kinds of ions, right? So what is this? This is the cyclopentadienyl ion. So as you can see, all of these have pi bonds or the pi electrons which it can easily donate. Any of the pi bonds or the pi electrons it can easily donate to the metal ion, and then it can form the coordination complex. Okay, so these are few examples of the category of ligands which are based on the donor and acceptor properties. So basically ligands are donors, but only in the case when they can act as acceptors are when they have any empty pi orbital which can accept an electron from the metal ion. So these are special categories, that is the sigma donor and pi acceptor ligands that we have seen in the first subcategory. Okay, so in detail you will learn about the sigma donor pi acceptor ligands when you will learn more about the nature of bonding between the metal and ligands in the coordination complexes. So hope this classification based on the acceptor and donor properties of the ligands is quite clear now, and hope it helps. Thank you.
So I hope you enjoyed today's video, and if you have any doubts or queries, please write to me in the comment section. Please like, share and subscribe if you like my videos, and till then, thanks for watching.